Welcome to the last episode of the Let's Make a VR Game series. What a journey it has been, and I hope that you enjoy following along. Now, in the last episode, we are going to do the final optimization to our game. I'm going to show you how to optimize the 3D model, the lighting, the project settings, and finally, we are going to build our game for desktop and Android to publish it on itch.io. As always, feel free to subscribe down below, and if you'd like to support my work and get access to the Result Unity project, I will leave in the description my Patreon. But without further ado, let's get started. Okay guys, here you go. We are almost done with our game. The last step is to optimize this beautiful scene to make it work on any platform and make it run smoothly. Now, how can we know if our game is optimized? Well, there is ways. In the Unity editor, you have the profiler, which you can open by going here at tab, profiler, and which will give you plenty information about the different usage of your CPU, of the rendering, of the memory, the audio, the physics, and so on. Now, this is one way to know if your game lags and is poorly optimized. The other way is to simply go in the game view here and click on the stats. As you can see, it did give you some information about the batches, the number of triangles seen by the players, but also about the frame per second. Now, this is of course working inside the Unity editor, but if you want to know if your game runs poorly when it's built, so outside of the Unity editor, you can do so by using this awesome performance head-up display tool, which is a tool made by Oculus, which will display the frame rate inside the application. Now, more simply, you can also create a little script that will compute the frame per second of your game and display it in front of your camera. And for this, I recommend this awesome tutorial made by Fistful of String about how to add frame per second in your game. Okay, so this is the first step. Now, to analyze the performance of your game. Now, we won't go too much into details about this because what I really want to show you in these tutorials is the little tips and tricks that you can use to make your VR game run smoothly but keep the same visual aesthetic. And so for this, I present to you the optimization checklist. Now, as you can see, the first two steps of the optimization checklist are the 3D model optimization and the complexity optimization. Now, these are just names that I made up here on the spot. But anyway, the first thing that you want to make sure when building a VR game is to make sure that the 3D model that you use are well optimized. This means that they have not a lot of triangles, that in most cases they share the same material. So this will mean here that the number of material that you use in your project is as small as possible. And finally, that the shaders that are used are also optimized. Now, if we have a look at our project, as you can see, all of the 3D models that we've used here are really simple. And if we have a look at the material, they all share the same material, which is this base color one. And by default, we are using here the universal render pipeline lit. We could kind of optimize it a bit better by going to universal render pipeline and select the simple lit. But anyway, I will just leave it like this for now. But with this, you can see that our little VR game has already the first point completed. As first, the 3D models are pretty simple. They shared for most of the 3D model the same material. And finally, that the shadow that is used is not that complicated. So let's just go here and we can simply cross the first one. Okay, for the second one, the complexity optimization. Of course, the 3D model in your games are important, but the different interaction that you use are also. For example, is the physics optimized? Now, in the case of this VR game, we are using a minimalistic physics setup. We can grab object, we can move around, and that's it. So we are not using a lot of physical joint, for example, which make this physics VR game not too complicated. Of course, you can kind of design your VR game in a way to not use too many physical components, or you can also go to Edit, Project Settings, and here on Physics, if you remember, there are some settings that you can use to kind of increase or decrease the physical computation of your game. Now, in our case, I think I will just leave it like this, as the physics is not the bottleneck for this application, as we are not using a lot of it. Now, regarding physics, another thing that we can talk is that you should not use mesh collider. You should keep using box and capsule and sphere collider. And another thing is that if you are using a rigid body, so for example, here on this gun, you should set the collision detection to discrete. Okay, so that's the first step about the complexity optimization. We can cross here our physics optimization as it is already handled in the game. And now for the next one, the script optimization. Well, by default, we don't have a lot of computation that we've done inside the little script because most of the interaction of our game are also pretty simple. Now, this is a choice, of course, by design, but if you are making lots of computation within your VR game, I don't know what it can be. Maybe you are processing a lot of data on the back end or anything. But in the case of this VR game, we are not doing any of this. So let me just skip this. Now for the visual effect optimization, this is mostly, are the particle systems in our game optimized? Are they not too many? Are the post-processing effect optimized? Are they not too many? And in the case of this VR game, if you remember, we can go to our post-processing volume, and the only two post-processing that we've added are here the bloom and the color curve here, so nothing fancy. Okay, so we can cross here this last one and we can go to the next step, to static optimization. And that's something that is not handled already by our VR game. So why is it important to know if an object is static or not in our game? First, it is because a common technique to optimize a scene is to use what's called a static batching. So basically, all the objects that are not moving, if they share a same material, will be batched together and sent to the GPU to be drawn on the screen. And secondly, having static object can also improve the lighting settings, and that's something that we will talk about later on. Now, anyway, as you remember, we had this static environment game object, which was the parent of all of our environment. Now, since then, we've done a lot of improvement in our game, and our hierarchy is not that well organized. So if we go, for example, under here or interactable, you can see that there are some static objects that are under interactable, like the trash, the space vacuum, the vortex, the energy analyzer, and the ladder. So we can select them all and drag them under the static environment. Now, all of them will not move in our game, so that's why I'm doing this. Now for the sci-fi pistol, we can drag it under the interactable. Same goes for the space waste interactable, and for the teleport anchor and for the teleport area. Okay, here you go. Now this way, we have set up all of the interactable under our interactable and all of the static things in our game under here, the static environment. And with this, what we can do is go at the top of the static environment and select this static icon. We can set yes, change children. So this will make sure that all of the children of this game object will be marked as static as well. And now by doing this and telling Unity what is moving and what is not, it can better optimize our game by default. Now that's awesome. And now back to our checklist, we can cross this one and it sends us to the lighting optimization. Now, if we have a look at our lighting right now, it is in real time, which means that if I take one of the light and that I move it around, as you can see, the blue light is changing in real time, which is really good. You have here the shadow that is moving also in real time. But of course, you guessed it, this is computer heavy. Oh, and by the way, here I remarked that this lighting post is not marked as static because I've placed them under this lighting game object. So what we can do is simply select all of these light corners and set them to static as well. This way, this game object will be static as well with the others as they are not moving. Now anyway, here are the steps to bake the lighting in our game and make it more optimized while keep the same visual aesthetic. The first step is what we've done previously, which is to say what is static and what is not. And the second step is to say if our light will be real-time or baked. For this, let's go to Windows, Rendering, Light Explorer, and here we can have a look at all of the light in our game. Now, as you can see, here are all the blue lights. So we can select them with the caps key. And as you can see, they are all in real time. Now, in my case, I want them all to be baked. There you go. But now, because these are baked light, we can set their shadow to soft shadows. Now that they will be baked, we don't care if they have a shadow or not, because the shadow that they make will be baked, so they will not be computed at every frame of the game, which is why we can do this now. Anyway, now we have 3 more light. We have a directional light, we have a point line, and another point line. So 3 point line that are real time right now. And this is where basically you can say what you want to be baked or not. For example, if you don't want any real-time shadow to be computed, you can select them all and set the mode to be baked. But in my case, I still want some real-time computation to occur. So I think what I'm going to do is set the directional line to be mixed. Now, mixed means that the light will be baked, but it will still light non-static objects. Now, after setting the directional line to mixed, let's go to our next one, which is this point light, which is located in the spaceship control room. Now, on this one, I don't want it to be mixed, so I'm going to set it to bake. And finally, the last one is this one in the start zone on the spaceship. And I'm simply going to set it from real time to mixed. And there you go. This way, we will have just 2 lights that will compute every frame of the game. But of course, if you want your VR game to be more optimized, you can set all of the light to bake. But in my case, I think it will be enough considering the complexity of my scene to leave 2 lights unbaked. Now, anyway, the light setup is done. We can close these windows. And now we can add 2 things. We can add a reflection probe. And if I go to right click, light, then reflection probe. Now the goal of a reflection probe is to do a bit the same like the lighting, which is bake the complexity of our scene somewhere, but to do so with the reflection. So after creating a reflection probe, we can place it in a certain zone and we can change here its box size to make it fit more or less the size of our game. So in my case, I'm going to add 2 reflection probe, one over there, and then duplicate this reflection probe to add a second one on the control room. And there we go. Now, as you can see, I have 2 reflection probe in my scene, which will be able to bake the reflection of our game. But that's not it. Now, remember that all of these blue light now are baked, which means that if the player approach his hand towards the blue light, well, the hand will keep their initial color and not take the blue tint from this light. But there is a technique to actually fix this little issue, and it's to use a light probe. So if we right click, go to light, and then go to light probe group, we can place it over there. There you go. Now, as you can see, a light probe group is basically some point here. And this point will bake the lighting surrounding them and apply it to the non-baked object around the scene. So this light probe group will be the solution for our little issue. And what we can do is simply place it somewhere in our scene like this, and then click on Edit Light Probe Group. Now what we can do is here, select them all like this, and we can move one or multiple light probe. And if we press on Ctrl D, as you can see, we can start putting them everywhere in our world. Now, of course, the more light probe you make, the more details on the baked lighting will be able to apply on the non-baked lighting. Now, before starting this tutorial, I've already done it and save it as a prefab here. So I can simply now drag it in our scene, and there it is. Now I can simply remove the other light probe group. And there you go. Now, as you can see, I have the light probe set for all of the environments. And with this, all of the steps to bake the lighting are completed. Now, remember that we set some object to static. We set the light to baked. We added some reflection probe to bake the reflection. And we added the light probe to be able to have some non-baked object be lit by the baked one. So the final step is, of course, to do the baking itself. And to do so, we need to go to Windows, Rendering, Lighting, and this should open here the lighting settings. So here we have no lighting setting assets. So let's click on New. Beautiful. For the light mapper, I'm going to set it to GPU. Now I'm going to keep the light map resolution to 40, but if the computation takes too long, you can reduce this value. Then I'm going to check here the ambient occlusion. which will add a nice ambient occlusion effect in our scene, which are some added shadows when two mesh collide. And finally, I'm going to set the max light map size to 2048. And there you go, now everything is ready. Let's click on generate lighting to generate and bake the lighting of our scene into a light map. And there you go, believe it or not, but the baking is finished. Now, as you can see, it looks a little bit nicer than before, but actually this is way more optimized. Now, for example, if I take this light right there and then I try to move it, as you can see, the lighting doesn't change on this post. And so, as you can see, everything is now baked. Now, little tips for you watching this video. You can also have a look at this light map by going to here, shading mode, and click on bake light map. And here you can have a look at how the light map is directly applying to our scene. And as you can see, everything looks great, which means that we successfully managed to bake the light map for our game. Okay, let's go back to shading mode, shaded. There you go. I'm in love with the look that we've made on our game. It really looks great. And this means that we can now go back to our optimization checklist and then check here the lighting optimization as we've done everything on it. And now the next thing is the project setting optimization. Okay, so for now, if we go to edit, project settings, and then on quality, as you can see, we have 3 levels of quality for our game. We have height fidelity, which is selected right now, balance, and performance. Now I'm going to just remove performance. There you go. And check the height fidelity only when we are on desktop and the performance only when we are on Android. Now, basically nothing has changed, but this means that when we build the game for desktop, we will have these levels of fidelity. And when we build for Android, we will have performance. But if we build right now, this is not the look that we will have for Android. No, because if we select performance, now this is the look that you will see. And as you can see, everything is flat, and I will show you why. So basically at this point, this means that we have now 2 settings. One settings for the high fidelity that will be used for desktop, and another one that will be used for building on Android, so on the MetaQuest. In my case, I'm not going to modify the setting of the high fidelity, which I think are fine by default, but I think that we can slightly improve the performance settings that will be used when we build on Android. So let me show you how. First thing is to go here on texture streaming and to enable it. We go below, we have a bunch of other settings that are just fine like this. But if we click on the render pipeline asset, as you can see, this will highlight a certain setting in the project files that we can click on. And if we go to inspector, there it is. Now, this is an important page here because these are all the settings that are used to render on our game. By default, the URP performance, as the name suggests, is very performant. But in the case of this VR game, we can slightly improve it a little bit better. For example, the HDR that is used by the bloom, we can enable it. And as you can see, we can now see the bloom again, on, off, on, off. Now for the anti-aliasing, this is a setting for me which is very important because the anti-aliasing can kind of remove the pixelization effect that we don't want on low-end device. So in my case, I will set it to 4, but if it's too much, you can of course set it to 2. Then for the main light, in my case, I want to cast some shadow. We can then go to additional light. And now if you remember, if we go to edit, rendering, light explorer, we add 2 mixed light. We add the mixed directional light and the mixed point light. So this means that if we go to our settings, we need also to enable this 2 light over there. Now, in the case that you only have 1 light, you can simply set the additional light to disable. But in the case, as I am right now with 2 light, I'm going to set it to per pixel and set the per object limit to 1. There you go. Now this additional light can cast some shadows. And as you can see with this, we are now able to see a little shadows of the end that are casted by this light over there. But this shadow is a bit blurred right now. But we can improve the shadow atlas resolution with setting it from 512 to 1024. or you can even go higher and set it to 2048 and do the same for the main shadow resolution. Now, this will depend really if your game can manage it. In my case, I still think that 1024 will be enough, so I will just leave it like this. Anyway, now if we go below, we can see the shadow max distance. Now, this is a very important setting because we, of course, don't want shadows to be displayed after a certain distance. And there you go. Now, as you can see, if we decrease this value, it kind of hides all of the shadow that are casted by the real-time object that are not baked. Now, what I like to do is go to the maximum distance here on the scene windows, have a look at the object that I want to study their shadow, and see how I can increase these settings to keep the shadow seen by the players. And as you can see, if I go to a value of 8, I can still see the shadows. And this feels like it is the minimal value for this. And of course, you want to set this max distance as low as possible. So 8 feels like a good amount. Now let's go down below. You can here increase the cascade count, which will allow you to kind of blend between two resolution of shadow. And finally, you have here the soft shadow that you can enable. And basically, that's it with the settings of our project. With this, we have created kind of an optimized settings for our game. Of course, feel free to tweak it yourself and to play around the result. But now I think that the result is great. We can now go to our optimization checklist and just cross here the project setting optimization. And the last thing missing is the culling. So this main camera by default will only render what's inside here, this view frustum. So inside the field of view of the camera. But you can also create a maximum distance. And here, this is by the far plane. So maybe we can reduce this far plane to something a bit less. There you go. Or maybe 200 seems good enough. Now, my goal, of course, is to still be able to see the little asteroid here. So 200 feels really great. And this is basically a technique that you can kind of use to make sure that the objects that are not too far away can still be seen by the camera. But that's not it, because you have the frustum culling, which is the technique that only render what's inside the field of view of the player. But you have also the occlusion culling within Unity. So the occlusion culling will means that if you are looking in this direction, for example, so in the direction of the door, you will not render the objects that are hidden by the door, which, for example, is this ladder. So for this, it's very simple. We simply need to go to Windows, Rendering, Occlusion Culling, and here we can simply click on Bake. And now if we wait a little bit, as you can see, it is already working. Now if we take the XR origin and that we rotate it around, here is what's happening. Now, as you can see, this is making sure to always display the only thing that the player is seeing in front of him. So that's another great optimization technique that is really easy to do. Okay, and just before finishing here this optimization part, something that I completely forgot is that if we take a look at this door is set to static. But it is not static because this door, of course, needs to open. So here, make sure to uncheck these parameters to make sure that when the player press on the button over there, it can still open. Now for this, I'm going to go in under the static environment and drag the door not under the static, but under the interactable over there. Beautiful. And there you go. Now you know what that means. We can go back to our optimization checklist and remove the last one, which means that we have successfully managed to optimize our VR game. So congratulations. Now it is time to build a game to test if what we made is well optimized. Okay, and to do so, let's go to File, Build Settings. Now remember, this is where we can build our VR game. But just before clicking on the build and run, let's go to player settings. And here on the company name, I'm going to simply write Valem. Then on the product name, Spacecraper is fine. Now for the default icon, before recording this video, I made a very cool icon over there that we can simply drag here. Beautiful. Now let's close. And finally, let's click on build and run to build our game. And there you go, after a little bit more than 10 minutes, the game is now built and we can see it over there with the beautiful icon that we've created. Now, as you can see, the game still works beautifully outside of Unity. Okay, so now that we built the game for desktop, I'm going to simply right-click and zip the file so that we will be able to share it more easily. Now it is time to build it not for Windows but for Android. So let's select Android over there and click on Switch Platform, and now get ready to wait a little bit longer. Okay, and here you go. Now everything is working well. And we have currently managed to switch platform to Android. And as you can see, the scene is still looking great. But now, of course, now that we have switched the platform, we can build to Android to directly output this game to the Oculus Quest. So I'm simply going to click on Build and Run and go to Builds, then create a new folder called Android Build. And now let's just hope that everything will work. And there you go, guys. Now I'm inside my Quest, so no more external computer involved. Purely the Oculus Quest handling all of the job here, and for now everything seems to work. I can still see the beautiful menu, and let's start and go inside the spaceship. And there you go, guys. As you can see, everything runs smoothly and the VR game is now completed. We have successfully managed to create a build for desktop, but also for Android, and everything runs smoothly. Now, congratulations if you managed to get to this part. And for my final trick, the thing that I want to show you is that now that we have a build that is working for Android and for desktop, what we can do is actually publish it on a web store that will be able to store our VR game. Now, in my case, I will simply post the Space Creeper here on itch.io. Now, it is very simple. You simply need to create a developer account. And then if you go at the top and select Upload New Project, you should be able to see this, and where you can fill all of the details of your game, like the title, the short description, and so on. I've also added some screenshot and some GIF about it with an icon over there. And here we can upload the file, so let's click on Upload. Now we can select our desktop build and click on Open. We can click again on Upload File, but this time select the APK. And there you go, now that the two builds are uploaded. We can simply go below, set the visibility to public, and click on Save. And now if we click on a view page, as you can see, I've already done a little bit of beautiful work here to showcase the game in its best shape. And now, as you can see, you can send this link to all of your friends, and they will be able to download your game from this page. This is awesome. And there you go, guys. Well, all good things come to an end, and while this is not the last tutorial that you will see on this channel, this is the last episode of this series. I want to particularly thank you all for following along, and to all the awesome Patreon who are the one making it possible for me to do this. Of course, you can join them to get access to the complete final Unity project, and if you just want to try the game, I will leave in the description the link for the itch.io page. Now that this series is over, I want to hear what you think about it and what I should cover in the next video. Thank you for watching, and see you very soon. Bye bye.